stress those out. Could you just put this on?
Yeah.
This is one I'm going to Katie.
Okay, cool.
Closer to the, yeah, right.
All right. Okay. All right, beautiful. So let's discuss our entry ticket. Let's talk about the exit ticket as well. Let's discuss the student error analysis. So we did the exit ticket yesterday. Our entry ticket is very similar, but now we're going to talk about student error analysis. So what do we notice was the error in the student's work? One hand. One hand. We're talking about what we did yesterday. So what was the student error's work? So let's start with, they're the same question. But let's just start with annotating this problem then. What did I ask you guys to do differently today that I didn't specifically say yesterday? What was the first thing you had to do? Raymond?
We had to,
Yeah, let's define our variables. All right, so go ahead and help me out. Melvin, what two variables are we given and how can we define them? M and F. All right, so how can we define M? What is M equal to? McGee. So let M equal McGee. McGee what? His earnings. So F would be whose earnings? All right, so let's go ahead and have that. If you did not define your variables from before, always make sure that you define them. This is an important step for the regents. You have to define your variables. So let M equals McGee's earnings. Let F equal Fitzpatrick's earnings. I got it, Malak. Thank you. You got to define them first. Before we even start anything, we define our variables first. So M is for McGee's earnings. F is for Fitzpatrick's earnings. Beautiful. Thank you. Jose, he's not here. Thank you. All right, so now that we define our variables, let's annotate the problem. What do we know specifically about McGee? Now I have a little bit more hands. Okay, go ahead, Jen.
His earnings were $0.005 million more than 15.
Okay. What does more than mean? What operation is addition, right? So some of us got a little bit confused, or let's talk about that student error from the exit ticket. What was the error then? What did they put as the equation for McGee? Jariah? Okay, so if we go back and read this, do we agree with that equation? Okay, one hand is, I only see one hand, but I have a lot of no's. Let me hear why we disagree. Let me hear from first Raymond and then Adriana.
I disagree because since it's saying that McGee's earnings are $0.005 million more, it should be F plus 0.005 equals M, because in order to get from Fitzpatrick's earnings to McGee's earnings, you need to add 0.005 to F.
All right, well, you're going to agree with that, Adriana, or add on to that?
And the only way it could be true is if you subtract it, like the first equation, if you subtract it.
Okay, so you're saying subtract what? Be more specific.
M minus 0.005 equals M.
Good. So Raymond and Adriana are both saying that McGee's earning equals 0.005 plus Fitzgerald earning. So if we have this equation and we agree with Raymond and Adriana, which answer choices could we have eliminated already off the bat? Elio? 1 and 3. Do we agree?
Yeah.
Okay, good. So now we have two answer choices here, 2 and 4. We have to keep reading to figure out which one is going to give us the right answer choices. 2 players earned a total of $3.95 million. What does that mean? How can I write that as an expression? I want to hear from that side. I haven't heard from that side of the table yet. How can I write this expression that 2 players earned a total of $3.95 million? Go ahead, Sam. Where'd you get M plus F from?
When they were saying Mickey's earnings and Fitzpatrick's earnings F.
So these two players together earn total means what? Equal, right? 3.95 million. So now we have our two equations. So what's the answer choices that that's the correct answer choice? 4. Right? So those of us that circled 1, that student error analysis, make sure that we have the correct equation for that first one. We know what McGee equals, not what Fitzpatrick equals after this. Are there any questions on this entry ticket / yesterday's exit ticket? You can now compare and see where you got your points off for. If you got 100%, you had this, all of this. If you lost points, it's because you weren't, you had some annotations you were missing.
That equation that young lady gave for the subtraction is brilliant. It would be nice to see if they could take that equation, in one step it becomes the other equation. If they notice how to get there. I mean, it's something to push, but that was nice.
Okay.
Yeah.
All right. Now that we have that, please follow along with me back to your launch from yesterday. Yesterday we worked on medium. Today we're going to work on spicy. So put your entry tickets to the side for now. We are going to work on the spicy part of today's lesson. So go ahead and take out yesterday's lesson. Take 30 more seconds. After, because the exit ticket is on the back.
Nah, so you see,
You don't have it?
I think I have it.
You sure? Because I figured somebody was going to misplace one. Ah, nice. 10 more seconds. 10, 9,
This whole table there.
8.
I may or may not have thrown out the packet when I was cleaning out my book bag because I had like 28 million.
7, yeah.
That's why Miss Georgia has an extra because we're throwing out stuff.
Yeah. Anybody else? Silent hand? Not Jiraiya. It can't be Jiraiya. Oh, okay. Yes. You were absent, yes. Yes. What happened to your packet yesterday? All right, we're here. Thank you. Thank you. All right, so let's turn to the launch part, not the spicy section, but the actual launch. And then you're looking for the spicy question. So go to the launch, where it says launch. And then you should see spicy. Thumbs up to let me know that you're there. Turn to the launch first. Good. This table's good. Yep, packet we used yesterday. Beautiful. It's, yep, launch. Got it. All right. Jose, take out your classwork from yesterday.
Example 2, no? I'm not telling you, Ashley.
Oh.
I thought you said you said.
Yeah, they're similar, but I could do example 2 first, and then do the spicy. I did this. I set them up with the spicy, and then had some students try example 2 on their own. But I could do both.
Oh, okay, yeah. I'm watching you.
Okay.
I already know what to do.
All right, well, we're there. All right, bring it back in 3.
I can now just solve this graph.
Bring it back in 2. And we're back at 1. Right now, I can shout out this table. Who's ready? Yes, Dylan? Your launch page? All right. So now that we're all here and we're at the launch, yesterday's packet. Edwin, can you go ahead and please read it out loud for us?
We're on page 2.
4.7, Jose.
Page 2.
Wait 1 second. Louder. Whoa, 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 whoa. Hold on 1 second. Jose, yesterday's packet. Have a seat. 4.7. Lunch. Go ahead. One more time, Edwin. Okay, beautiful. I already see some of us annotating. We already know what we have to do. Let's talk about what the 2 things that we have here. What 2 things do we have here? Wait, sorry. What 2 things do we have here? Silent hand. What 2 things do we have? Silent hand, silent hand, silent hand. Go back to the word problem. I'm asking you guys to do anything yet. Just describe to me what we have here. What are the 2 things we have? Kaylee, what 2 things do we have? Yeah, so let's go ahead and just divide your page in half. Type A, type B. We're going to focus on type A. I'm going to model that with you guys. I'm going to have you guys do type B on your own. So what do we know about type A? What's given to me from this word problem about type A? Ezekiel. Good. The current height is 3 feet. Oh, I heard that word. What is that? Our constant.
Also called y-intercept.
Ooh.
IV.
Independent variable.
No.
Initial
value.
That's same thing, guys.
Yes.
What's the next thing that we have? Young man up here.
Huh?
Yeah.
Type.
Only focus on type A. Type
Type
A.
A together.
That it goes at a rate of 15 inches per
Good
minute.
job, sir.
Good.
So what is that called? Use the word rate. What is, no, stay with him. What is that called? The rate is the what?
What's another word for rate?
No, Mr. Lyons, they heard that 20,000 times in this room. What is that called?
You know it.
You use the rate. What's another word for rate?
If we have y-intercept, what's the other one? What's another word?
You cannot give it away. You are not taking everybody's Regents exam. Did you hear what she said? Slope. Say it again. It's the slope.
We have the slope. So we have our y-intercept, we have our slope. So if we have our y-intercept, we have our slope, we can come up with what? An equation. What is the equation we could come up with for type A?
Everybody writes it down.
Everybody.
Everybody writes down that equation. What's the equation for type A?
I got this side, Georgie.
All right.
Everybody write down the equation for type A. If you got the hang of this, write the equation for type B.
So go ahead. Get started.
Those 2 letters gotta be the same plus. So what letter are you gonna use?
Okay, so you have y equals mx plus b.
Yeah, but like why is means like years? Like,
Okay, I like that. Okay.
Y equals mx plus b.
So define your variables too.
I heard Ms. Georgie say define your variable.
Yeah, define your variables. So say what is y with. Okay, good. Could I see? Where are you? Can you guys put the drawings away?
He told me to flip the page because I got it right.
This one?
Yeah, I don't think it's right though.
No. Well, your equation, but you didn't finish.
I know that.
Okay, so you see if you can keep going. Okay. I was gonna set them up to like do this part and then convert it.
Do which part?
Convert it to inches so that they're both in inches. Do they need to do that? I think they do.
Actually, this actually needs to change.
Yeah, so I was gonna do that with them.
Oh, yeah, I didn't even notice that.
Yeah. No, it's okay.
Convert first.
Yeah, so once they have that, we just have them convert it now, then they can read.
Oh, yeah,
Did I do something wrong?
I would show call real quickly. I would show call her work. And because most kids have this, and then talk about the units.
Okay.
And then I would try to get an example too. Not solving it, just make sure they understand what each variable represents.
Yes.
And then talk about, is this 15, what is this 3? And then talk about converting.
Okay.
I think that's the spiciest part about it.
Okay. It's okay. All right, let's bring it back in 3. Let's bring it back in 2. And we're back in 1. So as I walked around, I saw many students' work looks very, very similar to this example here. Thank you. We set up our equation where we had, just looking at this part. Okay, so remember from back from our launch, we always have to do what first? Going back to our entry ticket. We have these beautiful variables here, but we have to do what with those variables first? Let's label them, define what they are, right? So if you didn't have that, make sure you define what your variables are. And then now let's also look at type A. Type A is 3 feet tall, but the rate is going at a rate of 15 inches per year. Feet and inches, are they the same units? No. So even though we have a really strong setup here, what do we have to do to our feet in order for our units to be the same? I heard it. Go ahead, Samir. Yeah, let's convert them to inches. How can we convert our feet to inches?
Feet is 24.
Ooh, let's think of a Subway sandwich.
Wait, 12? Wait, 12.
Yeah, a Subway sandwich, right? If you get a 12-inch Subway sandwich, that's a foot long, right? So we got to convert 12 inches is equal to 1 foot. How many feet do we have? 3. So how many inches will that be?
36.
All right, so let's rewrite this equation where it doesn't include our feet. But instead of saying 3 is going to be replaced with what number? Let's replace that with 36, right? So now we have, let's define our variables. We're saying h is our what? Our height?
Yeah.
And let y, you guys use y for what?
Inches? Oh, no.
Why do we use the variable y? Adriana?
About the year.
The years.
I was going to say.
So if you say let h equal height, let y equals years, the height is going to be equal to, we just said it's 36 plus 15 times the number of years. If you have this for type A, go ahead and do type B. Find an equation for type B. Good. So now that you know this, they have to have the same height. So what do you think that's going to be true about these equations? They have to be what compared to each other?
This.
Yep, so equal to one another. So put them equal to one another and solve. This 36 plus the 15y equals this plus that and solve.
Stamp with the second equation. Show if they have to be equal or set them equal to each other. When I'm going to solve, and then go to example.
Okay. We gotta do this first. Is it water you're gonna do quickly? Go ahead quickly, but I don't want you to miss this. Okay, perfect. Yep. All right. So now, JD, can you tell me the second equation you came up with?
48, h equals 48 plus 10y.
Okay, thumbs up if we all have agreements. I walked around and I definitely saw that around. Excellent. So we converted them all to inches. Now, these two, type A and type B, have to have the same height. If they have to have the same height, what must be true about these two equations? Same height. Oh, I see some thinking. I see more hands coming up. Sean, I haven't heard from you. They have to be equal. So what am I going to do? How can I get these equations to be equal?
What does that look
What does that look like? What would these two equations being equal to one another look like? Daniela?
It would be H equals H, so you would have to substitute each H for type A and type B.
All right. So let's do that. We have,
Tell us what to write.
yep, what do I have to write?
36 plus 15y equals 48 plus 10y.
All right. Now, we're not going to take time to solve it. For this example, we're going to jump into example 2, but this is how it would be set up, and then we would solve for our y. Any questions on the spicy? This problem.
If you hear your name, meet me outside. You're going to be Chris, Destiny, Skylar, Jen, Joshua. Real quick, real quick. I'm bringing it right back to you.
All right. All right.
George, maybe just for like 20
Have them
seconds
solve it.
unpack what made the problem spicy as opposed to easy. I think there was one minor thing that made it spicy.
Yeah,
Does anybody
absolutely.
want to maybe think about what made this problem a spicy problem as opposed to a medium or mild?
What made this question a little bit?
Well, there was something about the design of the problem that made it spicier than that first one you just referenced. What was specific? What did you have to do for this one that made it a little bit harder? I even missed it. Yes, say it again. You had to convert. They gave you 2 different units.
Yeah.
Change it to the other unit.
Correct.
Yes.
All right. So again, was that hard for you?
No.
You knew 3 feet was
36 inches.
exactly.
All right.
So
Beautiful. Okay, so whenever you guys see those kind of questions, just remember it's going to take an extra step, but it is feasible. Follow along with me to example 2. Page 5, example 2. Turn to example 2.
I annotated that.
Jose, not right now. Example 2. Can I have a student volunteer to read it out loud for us, please? Go ahead, Nyla.
Admission to the senior class talent show was $3.
Nyla, start over, louder.
Admission to the senior class talent show was $3.75 for students and $4.50 for adults. The senior class collected 1,680 from the sale of 400 tickets. Find the number of adults sold and the number of student tickets sold.
Okay, so before I have you guys try this on your own, what was the first thing we always have to do? Annotate and
Annotate in, like variables. Oh, wait.
define your variables. So go ahead and do that. Take 30 seconds. Annotate, define your variables. Let whatever variable you want. Good. Strong start, yeah.
Next thing to just like conceptual is see if they can take note. Oh, this problem that we just did was a slope-intercept form system. This one is a standard form system. Right, to see if they, don't tell them, see if they recognize it.
Okay.
Yeah, this is great.
I'm in. Hello.
Good. I like that.
Focus.
Yep.
Jesus Christ.
Good. Yeah. I like this equation. Make sure your coefficient goes in the front.
I'll be able to redirect you. That's your friend? That's your friend? He's asking you about what?
We shouldn't be doing that right now. We should be doing example 2.
Can you take one? I don't know. I did this yesterday.
Oh, yeah, me too.
Nice.
I just want to
I
see.
just chose
I
not
just
to redo
wanna
it.
see if it's correct.
Good.
Well, the first part. I think it's correct.
I like the annotations.
But can I get a
See
star?
if once you solve it, I'll give you a star. See if you can set it up and solve.
Wait, what do you mean so? Oh, like we did last time?
Oh, sorry. Beautiful. We're on this one now. We're here now. Come on, sweetie, follow along. I like this equation here. I would go back and double check this one though.
No, that was just an annotation.
Oh, okay, gotcha. Okay. I keep calling on you. I'm gonna call on you, Dylan. Tell me what the equation setup.
Oh.
Yeah, this part.
Was 400, so S plus A equals 400, right? And
What are your annotations? What are your annotations? Where's your? You're supposed to do with your equations. Yes, beautiful. Good.
Yeah, I'm seeing most students got the equation, and you want to make sure that they have it on the side, like the variables defined. Most kids have the equation. Now you have to distinguish whether elimination or substitution. Set up the substitution for them, because even EZE was struggling with knowing which one to use. So make sure they define the variable, stamp that, show the two equations. I think most of them got it. Set the elimination or substitution, set it up for them, give them the whole.
Okay.
If 10 kids
Yeah,
are
this
going
is
to a
good.
movie and 8
Let's talk
adults are
about
going
that
to a
one.
movie, when I add them together,
Double check
what do I
this one.
get?
This equation is good though.
No,
Love this.
18
Oh,
what?
okay, good. All right. Clap, 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 clap. Almost. Clap, 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 clap. Beautiful. As we walked around, I saw some strong setups. So let's go ahead and stamp it all together. Dylan, can you first tell me your variables, what you define them as, and the two system of equations you have set up?
So my equation was $3.75.
They gave it to
Before you give me the equation, define your variables for me.
S is for the student, and A is for adult.
A. I can't give this to you. No.
Okay?
The adult tickets and the student tickets.
My equation is $3.75. S plus $4.50. A equals 1,680.
Plus what?
How did you know that the 1,680 went with these numbers here and not something else? And they're both talking about cost. Good. And then what's the second equation you came up with?
S plus A equals 400.
Good.
Exactly. That's the easy.
Beautiful.
On your paper, the defined variables, make sure it's there.
So now we have our two system of equations. What do you notice about these equations that's slightly different than the previous one we looked at? Jariah? We don't have, so if it's not a, so what can we, how is it written? How is this one written now? What form is this?
Standard form.
Standard form, and previously is written in what? Slope-intercept form. Yes, right? So now we have standard form. It's written in standard form, okay? And so now that it's written in standard form, what process can we use to solve this equation? We have a system of equations. What process can we use to solve? I love that Jariah is going back to the anchor charts. Ezekiel? Substitution, or we could also use elimination. But I'm going to stick with what Ezekiel said here. I'm going to use substitution because I have coefficient of 1. It's easier to use substitution. Now, in order for me to use substitution, what must be true about this second equation? It has to be written in what?
Okay, so put it in slope-intercept form for us, everybody. S plus A equals 400. Put it into slope-intercept form, please. It takes exactly one step.